Hey guys, how's it going? So I've been sick the past week, and so I haven't been able to go to work thanks to COVID. And in that time, I have spent a lot of it building a Minecraft computer, and I kind of want to show it off. So yeah, let's take a look at it. All right, so one thing that you're probably noticing right off the bat is how much smaller than this is than like most other Minecraft PCs. And I'm actually quite proud of it. I did a lot of optimization and I read a lot of articles about certain computing subroutines. I really went back to the basics. So this is an emulation of an x86 processor. So in theory, this could run like Microsoft Windows. Of course, like a Minecraft computer is never going to be powerful enough to run Windows, but it is based off the x86 architecture, most specifically the 6502 processor. It has a complete feature set with that one, so we can run certain old computers, and we'll kind of talk about that a little bit later. So yeah, as I was saying, it's a lot smaller. So let's run through some of the things I did to make this substantially smaller, yet also more powerful than any of the other Minecraft computers you've probably seen on YouTube. So over here we have the pflop byte array, and this is commonly what you would recognize as a GPU. And you can't see it, but I'm using heavy air quotes because in this system, I've kind of repurposed the graphical capability for data processing. So in actuality, this has two processors. This one, it sets up the data to be computed. It takes inputs and it knocks those inputs down into mathematical equations that get fed into the CPU proper. And we'll talk a little bit later on about how the CPU works, because this is quite ingenious, if I do say so myself. And then over here we have what I find a kind of amusing visual pun. So this is our storage, and so I managed to calculate storage using a series of chests. Right now I only have it set up to store, oh gosh, how much memory do I have set up to store? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's right. Oh gosh, I need to get rid of 4 of those because that's probably under certain circumstances going to throw errors. But whatever, for right now, for demonstration purposes, it works. So I have 20 chests set up right here. So that means I'm able to hold 20 kilobytes of data. And yes, I said that right, kilobytes of data. That doesn't sound like a lot in practice, but remember, this is a Minecraft computer, guys. I'm pretty chuffed with myself. All right, so there's still some stuff I want to show off with this computer. But for now, I want to take a step back and let's look at the display. So you'll notice this is quite a bit different from the way that other Minecrafters have handled displays in the past. A lot of the time with computers, you'll see that they use like pistons to deform a plate that usually gives them a resolution of about 16 by 16, or else they'll use like a 7-segment display with like 7 or 8 spaces. But this is much better. So I used a system of maps on item frames. And this is kind of cheating, but I don't really consider it cheating since it's a peripheral, and I think this is pretty nifty. It's really the only practical way to have a display in Minecraft as well. So what I did is, I forget if I mentioned this already, it is maps on item frames. And so I take the output from the CPU and feed that into command blocks, which then deforms the terrain around the computer. I'll probably flash how that works up on screen. And so once it deforms the terrain, I have a really messy setup that I'm not ready to show off yet, where I use armor stands to quickly update the maps, so I can get about 30 frames per second. Not that that's really necessary for this kind of thing, but it's still pretty cool, right? Unfortunately, in-game, I don't have a method of input. I do have some buttons that I'm working on, but it's so hard to get those to work. But what I do have is actually kind of cooler. I have inbuilt networking. And so I have an actual router connected to this PC, and it's not running through the executable. It's not being run by my computer. It's actually being emulated inside the game by my CPU. And so I get all input by directly connecting to this computer from outside mine. And you know what, I'll show that real quick. All right, so here we are with my setup. On the right over here, I have the code that I wrote. This just handles the actual networking. Getting it to work in Minecraft itself was a bit trickier. That's another video I'm going to have to make, because that was the real hard part about this, is getting network adapters to work on a virtual computer inside of Minecraft, but eventually we got there. So hopefully within the next month I'll have a video up about how to handle in-game networking. All right, so in order to actually get into this, we're going to have to save and quit title. And all right, let's see if I can remember the address of the server I set up that runs through Minecraft. sh 1.17.1 dot connect, and I've got to parse the port parameter. So I gotta find out what my port is. Sorry, I am woefully unprepared. I had to do this like twice when I was first building this, and I haven't done it since. Okay, yeah. So I've got to connect to port 200 and fix this little typo. And since this is running on my own machine, I have to establish the latency. I found that a latency of 0 actually completely screws up Minecraft. I don't know why that is. I have to have at least a 10 millisecond delay between sending and receiving, otherwise it crashes the game. So we just do lat.set. Then just for a bit of a buffer, I'm going to do 20 milliseconds. And now we need the actual address. So that is 192.168. And this is a local server. I'm connecting to a server being hosted on this machine by the machine itself, so I'm not going through a router. So we add .0.127. That didn't work. Let's see. You know what? Those are supposed to be not. Let's see. Here we go. Let's see if this works. Okay, here we go. Sick. Try it one more time. As far as I can tell, I typed it right, but I guess that just didn't want to work. So now I just have to type in my password and okay, sick. We are in. So I made a few additions to this code. So now that we are in here, we can do shell.src push. And okay. Perfect. So now we can just go back into, I forget which one it is, this one. All right, we're back here, and you can see that I didn't really do much with that program. I just changed the background color. I still have to write a more fully featured operating system, but right now, yeah, that works. I also read out a quick little hello world prompt. See, I made a typo, but whatever, it's fine. So I feel like I should explain what makes this so much smaller than any other of the Minecraft computers out there. I use some Catmull-Clark regression algorithms to cut down on the amount of binary data. So what that means is I can extrapolate 8 bits of data from each byte. And that speeds up computation by anywhere from, I'd say, 12 to 17%. Oh man, okay. So you can see something's going wrong. I don't think it's my code. Let's go check on the CPU. That's usually the issue. I've still got some bugs to work out with the CPU. All right, let's see what's wrong with this. So coming up here, you can see that we have 35, I don't remember the exact number, 35 compute nodes, and this one seems to be broken. So this gives me a good chance to explain how the CPU works, I guess. I was going to save that for another video. So actually, I do this based on slave labor. So you remember how I was talking about how there are functionally 2 processors? So this gets all the data set up in a way so that I can just have the data solved mathematically by a bunch of villagers with slide rules. This guy has decided, as is unfortunately very common with these villagers when you've enslaved them, that he does not want to do any more calculations. Super simple fix. Just murder him. Be sure you tell the other villagers that you just killed one of them. That usually keeps any more of them from rebelling for 2 to 3 weeks. That's still off. Still going. Let's give him a minute to get familiar with the systems, and hopefully this node will be back online. Let's give it just a minute. Okay, awesome. You can see that that guy is now working in tip-top shape. Back to computing our numbers for us. When they're fresh, keep an eye on them. They kind of don't know how it works. You gotta lay the smack down on them a little bit. But that'll be good. We're set. One last thing before I go. Be sure to keep those villagers' families nearby, because if things ever get too bad, just burn that bitch down and start over somewhere fresh. Let them know they can't push you around. They are here for one task and one task only. But yeah, have a great day, y'all.